Hey guys, in today's video we're going to be looking at the periodic table. So at the end of this we should know how the elements are arranged within the periodic table, we should know what periods and groups are, and we should recall where in the periodic table the metals and non-metals are. So let's just take a quick look at what our periodic table looks like. So here is our periodic table, and it's going to be arranged by atomic number. And our atomic numbers go from 1 to 118. Our atomic number itself is the number of protons. And the number of protons determines what element we have. So if we have a specific number of protons, we're talking about a specific element. You change the number of protons, you're going to change the element that you have. We did talk about the idea of isotopes. Isotopes are atoms within an element that have the same number of protons, because to be an atom within an element, it has to have that same number of protons, but it has different number of neutrons, which gives it different masses. And on our periodic table, we see that reflected in our average or relative atomic mass. Our atomic mass or atomic weight is a weighted average of all of the isotope masses that exist naturally. Our periodic table itself is divided by metal, semi-metal, and non-metal, or metal, metalloid, and non-metal, where our metals are on the left side of the periodic table. Our semi-metals are on this stair step right here, and then our non-metals are on the right side of the periodic table. Below the periodic table, you see these two rows right here. These actually belong right there, but they're removed down to the bottom because if we were to keep them up at the top, that would make the periodic table very, very long. So they bring them down to the bottom so that the periodic table itself fits nicely onto a piece of paper. Okay, so our periodic table is arranged by metal, non-metal, and metalloid. Metals, metalloids, which are semi-metal, and non-metals. Within our metals, we have a couple of different groups that we're going to explore in later lectures, but our metals are going to include alkali metals, alkaline earth metals, transition metals, within our transition metals, we have coinage metals or noble metals, and they're coinage metals because they are the metals that coins are made out of. So they include silver, gold, and platinum. And then we have lanthanides and actinides. Then our nonmetals, we have pnictogens, we have chalcogens, halogens, and noble gases. And like I said, we're going to talk much more about each of these groups in a later lecture, but looking at the periodic table above, we can see where all of these, and then the one that's not labeled here are pnictogens, which is the nitrogen group. So make sure you can recognize where each of these are within the periodic table. Okay, the next thing I want to look at are the ideas of periods and groups. So periods are going to be our rows, and they go between 1 and 7. And then our groups are going to be our columns. And they go from 1 to 18. So if we look, 1, 2, 13, 14, 15, 16, 17, and 18, these are called main group elements. So there's going to be a lot of times throughout the course that I'm going to talk about main group elements and then non-main group elements, because main group elements usually follow trends a lot better than our non-main group elements. Our non-main group elements kind of do their own thing. But the arrangement of the elements in this way with the 18 different groups does help to make sure that our chemical properties end up the same within the group or similar within each group. So our groups are our vertical columns, remember. Okay, I want to specifically talk about metals, nonmetals, and a little bit about our metalloids. So metals are going to be shiny, ductile. Ductile means they can be pulled into a wire. Malleable, they can be beat into a shape without breaking. Electrically, and heat conductive. They can conduct electrons and heat. They easily give up electrons. And when they give up electrons, they are going to form a plus ion, a positively charged ion, which is called a cation. A positive ion, because it's a cat ion. Sorry. Anyways, okay. And most are solid at room temperature. The only exception to this is going to be mercury, which is a liquid at room temperature. And then gallium is a very, very low melting metal, so you can actually hold it in your hand and it'll melt. Then we have our nonmetals. Nonmetals are going to be dull, brittle, insulating, both electrically and heat-wise. They easily take electrons. And when they do, they form a negative anion or negative ion. And they are found in all states at room temperatures. So there are some nonmetals that are solids at room temperatures. There are some nonmetals that are liquid at room temperature, and then there are some nonmetals that are gases at room temperature. And then our metalloids. They're going to have properties between that of a metal and a nonmetal. So they are going to be somewhat conductive, and they're going to be somewhat brittle, somewhat malleable, generally more brittle, but they're not going to be too much like either group. Let's look at a couple of the groups a little bit more in detail. So for our metals, we have our alkali metals. This is group 1. And these are going to be very reactive. They are only found as ions. So they are not going to be found in what's considered the elemental form. So they're not going to be metallic in nature. They have been isolated and put under oil to keep them in their elemental form. But in nature, they're always going to be as an ion. And it's going to be a +1 ion. So they always form a +1 ion in a compound. Our next group are alkaline earth metals. These are group 2. These are fairly reactive. Most are only found as ions in nature, although some of them are found in their element form, so not as an ion. And then they always form +2 ions in a compound. Our next metal group are our transition metals. And these are groups 3 to 12. And they're going to have a lot of variability. So they're going to be highly colored, but they're going to be variable in their reactivities and charges. Okay. Next are our lanthanides. Lanthanides are the ones down below on the periodic table, the first row below the periodic table. And these are going to be soft and shiny. They're going to be fairly reactive, so most are reactive. They are going to be emissive as ions. And they usually form +3 ions. Okay. And then we have our actinides. Actinides, this is the only group where all of the elements are radioactive. And unstable. So when I say that they're radioactive, that means that they're all going to be unstable nuclei that are going to spontaneously decay to form our radioactive particles, our beta particles, our alpha particles, and our gamma rays. So every single element within our actinide group is considered radioactive. Other than that, they have similar properties to our lanthanides. And they form that +3 ion most usually. Okay, let's look at a couple of our non-metal groups. We have our pnictogens, which I'm sure I'm pronouncing wrong. So the name comes from 5, so it means 5, and it has to do with a lot of the compounds that nitrogen forms. But we're not going to really focus on that. Only thing I really want you guys to know today is if we are putting nitrogen or any of our pnictogens in an ionic compound, generally they're going to form a -3 ion. And that minus means we call it an anion. So in ionic compounds, our pnictogens are generally going to be -3. Okay, then we have our chalcogens. Chalcogen means ore forming, as most of them are found in ores. And they are generally going to form a -2 ion in ionic compounds. Okay. Next are our halogens. Halogen means salt forming. And they're going to form -1 ion in ionic compounds. And then lastly, our noble gases. These are considered inert, so unreactive. And most do not form compounds. Those that do, krypton and xenon, are not going to form very many. Okay, that's everything. I hope you guys know a little bit more about the periodic table. Bye, guys.